Good morning. Sorry. Good morning, everyone, and welcome at session 1B, monitoring and instrumentation, visualization. Sorry, and emphasizing on information portals. So you're in the right session. We have 1 hour, 3 presentations. These presentations will be 15 minutes sharp, and we will have 5 minutes to discuss. So I'd like to introduce first to you Kees de Gooijer. Kees de Gooijer is a consultant for information technology, and he got he did his civil engineering studies in Amsterdam. After that, he did design work in the sewerage division of DHV. While developing technical and scientific computer models. At the moment, he is with HKV Consultants as a consultant in information technology. And his presentation today, well, it's visible on the whiteboard. That's information management during regular and crisis situation. That's correct? Okay, Kees, please, the floor is yours.
Thank you for the introduction. Welcome. It's for me an honor to kick off here today at this conference. I'm glad there are a lot of people here in the room. So I can skip my own introduction. That was also done by Maarten. So we can go to the next slide. I want to tell you something about the system, what we called Success. It was developed in the flood control 2015 program by for the waterboard Groot Salland with a number of partners, and the most important were HKV Consultants ourselves. Yeah, it's not so nice to start with ourselves, but sorry for that. Deltares here in the Netherlands and Fugro joined the project. Yeah, sorry for that. It will happen maybe sometimes often. I first want to focus on the area where we from the waterboard Groot Salland, where we did the project, where we did the study. It's a part of the IJssel Delta, which is part of the Rhine Delta in the Netherlands. It's flat. It's close to the sea, to the what we call the IJsselmeer. It's close to an open area with some influence. The waterboard has primary levels on, let's say, the bigger water. They have regional levees on the smaller system, and they have also a number of inside other levees, which are better, more away from the bigger water systems. It's a complex water system. We have the IJssel with its discharge, especially in this part of the year until let's say autumn of March, April. We have smaller rivers. For instance, the Vecht, and we have here the lake with the influence of wind and the water rising by the wind, and that will come together in especially this area here. In that area, we have a storm surge barrier, Ramspol, which is used to protect the land behind the barrier, of course. And we have a special place, the city of Kampen, which is really close to the river, with it's, rather less protected by itself. And they built big mobile walls, with which are they use a lot of time to build them up, use a lot of handcraft for it. So they organized a dike what we call the dike army. I don't know if it's the good term in English, with 250 volunteers. They are trained weekly on different places in the city, different places on the barrier, and they have an exercise once a year. The barrier is here along the river IJssel, and it's sometimes very close to the river, and sometimes it's even in the old city wall, where they made a protection for the city behind it. And all, to prevent this type of flooding. What did we do? The water board, they had the objective. They wanted to have more and better information, but not only for the calamity situation. In the calamity situation, we need forecasts of water levels, the weather situation. We want to see the impact of these forecasts, this situation, and we want to know what can we do, what are our options, and what is the impact of our options, of our measures. But also in more day-by-day situations, the assessment, which we have to do by law here in the Netherlands, which comes back every couple of years. Also for that, we need information, and basically we want to try to use the same system, the same information, same to maintenance. We want to see, we want to have get a feeling by the balance of the impact and the objectives and the cost and the results of the measurements. And during policy, for policy and investments, what are we doing regarding water safety in the long term? The objectives of the water board, the organization we are doing the project for, they want to have continuous insight into the understanding of the water system, of the current situation and the expected situation, by collecting and using the water levels, the predicted, the forecasted water levels, to get information of the strength of the water of the dikes, and to have by that then information of the chance and the risk of flooding. How fast, what is the risk of the chance that it happened, and what is the impact then if it happens? By disclosing information and the direct translation for apply on the different scaling levels, which I mentioned already: calamity situation, assessment, policy, and maintenance. So the objective was to have one system which we can use in the different situation. An additional advantage for it is then that if you are in a calamity situation, you are used to use that system. Don't use a system only when there is a calamity, because then it's a risk. People are not trained well enough how to look to the results of the system. Yeah, and then for that we have, let's say, the traditional in the meantime, the traditional steps, which you can, which come back, and which, the circle from policy making in plans. Okay, that will give you input to the maintenance, and the next step, the assessment, and at the end, you look to the to the improvement and the design, and this will give you again input in for your new policy plans for the next steps. And our objective is that what we call a success system, but what's not only a system by itself, one system, will give input to these steps, but also will use the results to give input to the next step. The calamity situation is not heavy. We wanted basically to reduce the calamity situation to a more or less regular situation that is recognizable by the people who are involved. But a calamity situation has some different, I would say in IT terms, properties. It's an urgent problem. You don't have time. People are sometimes in a different role than in their regular situation. An organization, not only the organization, the water board, but also the other organizations involved, are scaled up, and they are more and more focused on the situation, and there is attention by other organizations, by people higher in higher organizations, but also by public and by the press. So therefore you need different skills or more additional attention. In the calamity situation, now I more want to focus to the system itself. In the calamity situation, we want to know what is the situation, what is what will be the situation, what are the forecasted, what is the forecasted situation, what can we do, what are our options, what is the impact from the measures we can take in the calamity situation, and then what are we going to do? Take the decision, what are we going to do, and to make it clear what the impact is on that. If you look to a certain example for a measure, what is looking to the levees, piping is a risk for the dike. But one of the measures we can take is that we rise the water level. We have on the outside of the dike, the water level is high. On the inside, the water level is low. And there is a risk that basically the water is going on weak places under the dike. What you can do is that we can, on the inside of the dike, that you can rise the water level so that you have a little bit more pressure to the outside. Using that measure, we can make calculations what the impact is for that measure. If we don't rise the water level for the project part, which is here on the map, the red sections are more or less in danger, and if you rise the level with a certain level, or the water level with a certain amount, then only these red places are in a certain danger. So you can, let's say, rise the protection level of the dikes. What we also want to provide with the system is that you make clear what the uncertainties are. And we have uncertainties in the weather situation, especially the wind in this part of the Netherlands, the wind speed, direction, and the wind power, in the water level, but of course also the bridge locations, where if it goes wrong, where it goes wrong, and based on that, we have then our flooding scenarios. And making clear the uncertainties, we can also react on these uncertainties and handle on that. During the assessment, we get the option to get insight in the information, the current situation of the water system, in a rather easy way. I said here to press one button to collect that information, because the structure is there. It's easier, it costs less time, it costs less effort.
2 minutes.
And 2 minutes. Okay, that's. Then I'm. Then I want to skip maybe some slides. Because now, where is the? Looking to the data and the information for the different levels, it's all over. It's in people's mind. It's on paper. It's in computers. So we have to bring that together. And for that we made the success system, which is built up based on existing systems, with on this part a fuse implementation, with 2 calculation models for the strength of the dike and to calculate the uncertainties. The interfaces in fuse of the data which it collects is validated, it's merged or it's aggregated, and the displays fuse provides are more or less for specialists. For decision makers, maintainers, other people in the organization, the information can be displayed on dashboards. And these dashboards are focused on the role someone has in the organization. And that could also be the public. The information that is collected is coming from inside and can come from outside. And these are some screenshots from the fuse system with diagrams combined, or grid displays, where you can see the risk of this is the risk for uplift by a really high water level. We can display the uncertainties on the water levels in this picture. And here we have some examples from different displays of in the dashboards. The dashboards, they are very flexible. You can make profiles for a certain role, for certain types of users, and even during the calamity situation, it's very easy to add or to skip information if it's available somewhere in the system. And especially for people outside the organization, the dashboard displays are also available on mobile display devices as smartphones and tablets. Then, sorry for to speed up a little bit. My main conclusion is that the information in the system want to provide information which is focused on the current situation, the current activity, the current upscaling level, but also the role for the different users involved. By adding especially the strength of the levee in the information system, so not only focusing on water levels, we want to improve the safety level, and on long term, using that, we hope also that we can reduce the cost on the short term and the long term investments.
Thank you, Kees. Well, it's pretty short, 15 minutes, but you made it to the conclusions. We have time for 2 short questions. Please state your name first. A first question might be, is this, from this information system, will data be available a posteriori for research purposes as well, once it's implemented?
It's an operational system, but there will be a lot of, let's say, information coming for also for research, because of course we want to continue, and this is the first step. There are a couple of companies involved, and for instance, Delta is still doing research to improve the module for calculating the strength of the levees, and we are still and also Delta is improving modules to calculate uncertainties. Mm-hmm. So of course it has to be an interaction between the reality, the organizations which are using it, and further research and further development.
Yeah. Okay. Yeah. Thanks. Any other very short question? Yeah. There's one question. Brief your name first. Briefly state your name first. Yeah.
Two things. You have the chance of flooding, and that is, will it happen? What is the chance that this will happen? And in the risk of flooding, there are the cost and all the other impacts that's brought together. So the risk includes cost, damage, maybe victims.
Okay, thank you, Kees de Gooijer, for your contribution. This doesn't work fine. So thanks very much.
Sure.
Yeah.